Well, you know what? I hit record to cloud. I think it's going to try to, okay, so I just hit record now. It looks like we're going to maybe, possibly get a video from this point on.
So
Okay.
wait.
Sorry, everyone.
Since
you started the review.
Turn it on its side.
If you turn it on its side,
Like it's a sideways McDonald's happy face.
like that, instead of the one that one looks like this. This one, if I make that negative, turns it upside down. This flips it on its side. And then, what do you think that one does?
That one, it turns it to the other side.
Okay.
Wait, would it be a function?
These are not functions, because look. 2 points above and below each other. These are not functions, but they are parabolic.
Wait, so the upside down one is a function? Because there's no point above and below?
This is a function, yeah.
What does it mean if there's 2 points horizontally though, not vertically?
That's fine. It means that multiple x's can have the same answer.
Oh.
What it doesn't mean though is that the one x can have multiple answers.
Okay.
Multiple x's can have the same answer, but one x cannot have multiple answers.
Yes.
Those sound to the ear like you're saying almost the same thing, but they're very different statements. Okay. All right. Ooh, I remember these. These are fun. Let me take this down to 375 perhaps. And see if it fits. Maybe 350. Yes, 350 worked. Okay. Can everybody see what it says?
Yeah.
Okay. Try to get ahead of me. See if you can do it. I have f of, I'm going to try to color code this to make it easy. Negative 2x plus 4. Oh, that should say f of h of x, not g. That's a misprint.
F of g.
Yeah,
I saw that on my review.
There would have to be a g function given to you, and there's not. So this would be either I change that to g, or I change that to h. We could change this one to g. G of x is equal to negative 3x minus 5. What I need is f of g of negative 6. Okay, so the first thing I want to do is take g of negative 6 and find out what that is, right there. And if you notice, that looks just like this, except negative 6 is substituting. So that means it substitutes in the equation. And that's all you're really doing. 18 minus 5 is 13. So g of negative 6 is 13. F of 13, so this, I'm going to rewrite this as f of, take this out and put this in. F of 13 means I'm going to use this equation and substitute for the x, 13.
What?
Why wouldn't I do that?
No, I'm just confused.
Okay, hold on. Go back up to the start. What did g of negative 6 mean for us to do? It meant for us first to go to the g, not the f. That's what the g told us to do. So you're ignoring this.
Okay.
Then it says to substitute negative 6 for x over here. So I substituted negative 6 here, got 13. That's what this is equal to in value. The problem wants me to find what f of g of negative 6 is. We now know what the value of g of negative 6 is, so we no longer need to write it as g of negative 6. We can replace it with the 13. Okay. So notice The black becomes the blue because I now know what g of negative 6 is. It's this. But now we know what that means to do, just like we knew what it meant to do here. It means that we go to the f equation now, ignore this one, and instead of x, put in a 13. So you'll notice I substituted 13 here, right here.
Mhm.
That gives me negative 26 plus 4, which is negative 22. And that's it. There's nothing else to do. So the answer to this was negative 22. This is my solution.
Okay.
It's a problem within a problem.
Yeah.
Any questions about that? Okay. Let's move on. Okay. Oh, good. I can keep the same size here. Notice the names. I usually use my family's names to do this. Jack has a gasoline credit card. So I changed the problem so it's not exactly the problem you see on the test, but it's so similar. I just changed the names of the people, and maybe instead of one type of credit card, I made it a gasoline card, you know? So it's the same idea though. So Jack has a gasoline credit card with a $200 balance. That means that he can only spend at most $200. He can't go over $200. He doesn't have to spend $200. So I'm feeling like this is going to be an inequality.
Greater than or equal to 200.
Maybe it's not an inequality because I'm looking ahead, I see an equation. Gasoline on a given day costs $3.50 per gallon.
Damn, that's cheap.
Well, it's actually cheaper now than that. That's what it was when I wrote the problem. The equation, y equals 200 minus 350x, is not, by the way, in slope-intercept form because that's not the slope. The negative 350 is the slope. Okay? The amount of money coming off of your credit card has to be negative to take away from the $200 you're starting with, right? So I would rewrite this right away onto my paper as negative. I would write it like this. Negative 350x plus the $200 that you get to start with on the gas card. And that represents, when you do that, let's say I get 1 gallon of gas, I have to take the 350 away from the $200 I have to spend. What's left over is what I have left on the card to spend. So that's why this Y represents how much is remaining on the card after I buy X gallons of gas. So then the problem that you'll be faced with on the test is these A and B here. Identify and interpret the X and Y intercepts. Round to the nearest tenth if necessary. So I need to find the X intercept and the Y intercept. How did we do that? 0 and 0. When X is 0, well, if it's in this form, the way that they trap you is they're hoping you pick this 350 or negative 350 on the end. But no, you need to rewrite it. It's the 200 is the Y-intercept. Okay? The X-intercept is when Y is 0, when you've run out of all your money, right? So the Y-intercept is when Y is 0 is when you're on the X-intercept. The X-intercept is when Y is 0, right? So you run out of all your money on your credit card. So basically you're finding out how many gallons of gas will it take to do that. Well, you can solve this. You might intuitively know, oh, I'll just divide $200 by 350 a gallon. And that'll tell me how many gallons before I run out of money. Okay, but algebraically, you can add 350 to both sides, which would neutralize it here and make it positive here. I'll take the 0. I don't need the 0 there. And then here's where you would get your division. Okay, and you can use your calculator at home.
Mr. Ethel,
Yeah.
if we did it on the test, like, not algebraically, just like that, just by dividing 200 by 350, is that okay?
I need to see your work. I want you to do it algebraically.
Okay.
About 57.
You do want to go to algebra, right?
Yes.
Do it algebraically.
Okay.
It's about 57.1 gallons. This is what I got on my calculator. Okay. All right, so if it's about 57.1 gallons, now it says identify and interpret. You have to say what these things mean. What does this mean? What is 57.1? By me putting gallons, I've done half of what it's asking me to do. If I just do 57.1, I've answered what the X intercept is. The X intercept is 57.1. The Y intercept is 200. But I have not interpreted them. What is the 200? It's dollars. What is the 57.1? It's gallons.
Gallons.
But that's not enough. That doesn't interpret it all the way. That's only half the interpretation. What is the full interpretation? What does the $200 represent?
How much money he has on his card when he doesn't spend any, when he doesn't get any gallons of gas.
Exactly. Wow, you nailed that one. That's exactly how you interpret it. 200 represents the maximum amount of money before he has before he's pumped any gas. What does the 57.1 gallons represent?
The gallons that he's then bought, and then he has no more money left.
Right. That's if he spends all of his money. That's the maximum amount of gasoline he can put on the card, charged to the card. Okay? That's the interpretation that you're going to need to put on the test. You cannot just put the X and Y intercept. I warn you, you will not get all the credit for this problem if you do that. Okay. Okay. Any questions about that so far?
Yes.
Mhm.
Why'd you put a 0 as the Y?
Because that's what an X intercept means. It's when on a graph, when you have a graph, where a line hits the y-axis is the y-intercept. Where it hits the x-axis is the x-intercept.
The Y is 0.
Hold on. When a possible coordinate for this could be what? Give me a possible coordinate right there.
0, 5.
0, 5 would be here.
5, 0.
Ah, what had to be 0?
The Y, because
Thank you. Thank you.
yeah.
What if the point's here? What could that coordinate be?
7, 5.
7, 5 would be up here.
7, 0.
Ah, see what has to be 0?
Yes.
If you don't know where the line's going to hit, then by me saying this part has to be 0, putting it into my equation and finding that, I now know that this is 57.10. See that? What I know is that no matter where it hits the x-axis, the coordinate has to have a y value of 0. And where it hits the y-axis, the x has to be 0. So this would be 0, 200.
0, 200. Wow, that's a big number.
Well, I mean, it doesn't matter. It's just that's what it is. At 0 gallons of gas used, you have $200 on the card. As you start to drive, or as you start to pump gas in, you are dropping your money. This is money. This is gallons of gas. Okay? Other questions about that first part?
Can you explain?
Guys, I'm going to have to mute everybody, and then you're going to unmute and ask your questions. Okay, mute all. Okay, now you can unmute if you have a question. I'm just trying to cut out the background noise.
Okay, I had a question. So, can you just say one more time, how you would interpret the x-intercept?
The x-intercept is when y is 0. So 57.1 gallons of gas is the maximum amount of gallons of gas you can put in the car when you spend all the money you have for the $200 that you have.
What I would have done on the thing was, like, immediately I would be like 200's the y-intercept, and then I would have said 3.5's the x-intercept. But that's not right, right? So
And it's not even the slope. The slope is negative 3.5.
okay. So it's asking for x-intercept and y-intercept, not slope and y. Okay.
Correct. Good. Anybody else question? Okay, going to B. Part B, you're going to get a bunch of points. You're going to get, maybe I'll give a point for identifying the x and y intercept, a point for interpreting, and a point for B. So let's see, for B, predict how many gallons of gas Jack has when the balance on the card is about $80. So when the balance is Y represents the balance, $80 is left. Then you just have to find out what X is to make it so that you have basically taken $120 away, right? How do you get $80 left when you start with 200? You're gonna
You have to subtract 120.
We shall restore the balance.
You guys, please. This is not the platform for that.
What?
You shall restore the balance. Oh, I see. You were making a joke about this. Never mind. Okay. I would solve this to find, okay, look, watch this. Neutralized, negative 120. Divide by negative 3.5. And a negative divided by a negative is a positive. And then you can use your calculator on the test. 34.3 about 34.3 gallons. Predict how many gallons of gas Jack has purchased when the balance on the card is about $80. So it's about 34.3 gallons of gas. At about 34.3 gallons of gas, Jack will have $80 left on the card.
I went into the hundredths. I rounded to the nearest hundred. Well,
We're going to
yeah.
do it to the nearest tenth.
Okay, only to the nearest tenth. Okay.
Yeah. Any other questions?
Wait, so wouldn't it be 34.4 gallons?
Let's see.
Because it's 34.38.
I got 34.28.
I think I divided on like without a calculator. So
You're pretty close.
okay.
Any other questions about this?
Yeah.
Go ahead.
Can you move your thing up a bit?
I'm sorry?
Can you move your
Move the screen up a bit, please. Thank
Okay, so
you.
how did you get where'd you get the so are you
Thank
doing
you.
between the two equations?
I'm sorry, what'd you say?
Are you doing subtraction between the two equations?
No,
Are you doing,
there's not two equations. This is not a system of equations.
He just inserted the 80.
This is the same equation, but it told me that there's a balance on the card of 80. So he told me what y is, that's all. It didn't give me a new relationship between the variables in the problem. That would be, a system of equations gives you two perspectives and relationships that we know something about two variables in a problem we're trying to solve.
you just do 80 minus 200, then you get 120 divided by
Negative 120.
Wait, once again, how is it you go about finding the x-intercept? Is there like an easy rule to always follow?
Yes, make y 0.
Okay.
Since when you cross the x-axis and you're on the x-axis at that point of crossing, all coordinates on the x-axis have a y coordinate of 0. All of them. So by making the y 0, that's what you're finding. You're finding the x, what x would have to be to make y 0 gives you the location of the x-intercept. Other questions about this problem? It's tricky. You got to know your stuff. Once you know your stuff, it's not so bad.
You said for interpreting the x and y intercepts, you just state what
What do they mean?
they represent.
What do they mean in the problem? In the
You
context of the-
state their roles that they represent in the problem.
That's right.
Okay.
Other questions? Okie doke.
Seems pretty easy.
Okay. All right. Now to go to some lighter stuff. Doesn't mean you're going to get the points for the lighter stuff. You could still make errors. It's just not, you're not trying to wrap your brain too much around all the words and meanings and stuff. It's just, do you know how to do it or not?
You skipped something.
Okay, so they want the slope and the y-intercept,
You
but it's in standard form. I skipped something?
Yeah.
A slide?
Yep.
I'll go back. So let's just do this one. Right now, the slope and y-intercept are not as easy to see unless you put it into slope-intercept form. The way we do that is we isolate y. So basically, I'm testing you to see if you know how to isolate the variable y. First thing I'm going to do is I'm going to subtract 4x on both sides. Neutralized over here. Don't forget that that's negative. A lot of students forget that's negative. They just put 15y and they get it wrong just right there. Second thing I want you to do is switch the order. Using the commutative property, instead of 75 plus a negative 4x, do negative 4x plus 75. Next, I want you to finish isolating y by dividing by negative 15 on the left. By the multiplication property of equality, you must also divide by negative 15 on the right. When you go to the right, you see there's two parts, two pieces to it. So you must distribute your division to each term. Divide by negative 15 here and here. And simplify. So this makes 1y. Here, a negative divided by a negative is positive 4/15. Leave it as a fraction. There's your slope. A positive divided by a negative is a negative or a minus. And that's just going to be 5. So, hello there, Jack.
I'm gonna have to go. Sorry.
Where- You okay?
Sorry.
No, it's okay.
You okay? Don't worry.
He's okay. All right, this is your slope. This is your y-intercept. Don't forget, it's negative 5, not 5.
So, when you're trying to isolate y in these problems, to find the slope, you just
Get it all the way into slope-intercept form.
okay.
There's your slope. There's your y-intercept with that sign. If it's plus, good. If it's minus, don't forget the minus. Some of you are going to forget the minus. If you say that the y-intercept is 5, you get it wrong. It's wrong. You get it all wrong. You must say that it's negative 5.
Where did the negative go in the slope?
Negative divided by a negative.
Oh.
Questions? Okay, moving along. I'm going to go up now. Graph a line with slope 0.4 and y-intercept negative 5. Okay, so the slope, I think I'm going to take the 0.4 and make that 2/5. Y-intercept negative 5.
Could you have made the slope 4/10?
Yeah. When you graph it, though, you're going to need to go up 4/10. I'd rather go up 2/5.
Okay.
There's -5. There's my y-intercept. And then I'm going to go up 2, and I'm going to go over 5. Done.
Mr. Rosenthal,
Uh-huh.
would you rather want us to do the simplified way, like how you converted it to 2/5, or could we do it however we want? Because I did it 4/10
If you
as well.
convert it into a fraction,
As long as your line is in that same location. If I were to go up 4, 1, 2, 3, 4, and go over 10, and you made a line, it would be in the same line. That's because the slope is constant between any 2 points. So between this point and the other point, that ratio, 4 over 10, is equal to 2 over 5. So it's going to still be the same steepness. It'll be the same line.
Okay.
Ms. Rosenthal,
Mm-hmm.
when x is 0, what line are you on? Are you on the x or y axis?
What this coordinate is.
That's 0, 5.
Which one is 0, the x or the y?
The x.
When x is 0, you're on the y-axis.
And when y is 0, you're on the x-axis?
Correct.
Okay, okay.
And that's a really important concept to soak in. And it's another concept that students need time to absorb. That's a normal for students to not absorb that completely right away. But at one point, it's just going to be normalized for you. You're going to understand that completely without, it's going to be autopilot for you. You just need to work with it a little bit more, and that'll be auto. You won't understand how you never saw it so simply. But it's just like anything else, riding a bike. Okay, moving along. Am I skipping? Oh, I think I'm skipping because it's loading. Yep, sure enough. Okay, we did this page 6, so now page 7. Here we go.
Mr. Rosenthal, wait.
You do page 5, remember?
Yeah, that was page 5. This is page 5.
Wait a second.
It was.
On page 5, like, does the line have to be exact? Because, like,
What does
the
that
line
mean?
that you... Because for the line that you made, you know, it obviously wasn't, like, the exact places it didn't cross through the exact places it was supposed to. But on the test, does it have to be, like, an exact line? Or is it just, like...
I don't know what you mean. These are in exact locations. That location is exactly 5, -3. This one is exactly at 0, -5. What do you mean? Do I want your lines to be drawn with a ruler and straight? Do I want your tick marks to be evenly spaced? Yes. Will I mark you off or even mark it wrong if the graph is so messy I cannot see? Yes. If you did it right, but your graph is so messy that it's inaccurate, is it going to be wrong? Yes. All right. So it needs to be an accurate line. Now, with the tools that I have on a board like this, the line's not going to be perfectly straight. On your paper, if you want, use a ruler so that your line is straight.
I'm just flew by. That it's
So-
early.
What was that?
Nothing.
All right. Yeah, we're definitely not going to finish the review today, but we will finish it tomorrow and take our test on Monday. Okay, what is true of the slopes? This is a weird, interesting question, but what is true of the slopes of segment AB and segment DE if the two triangles are similar? And then explaining why is important here. You're not going to get any credit at all unless you give me the why.
The slopes are the same.
Yeah, it's just different size and you're putting it different angles.
Why would they be the
The
same?
angles are congruent, so the slopes are the same.
The angles are, oh, that's an interesting way to say it. Okay, AB, what is true of the slopes AB? There's a slope of that line, that segment, and DE, there's a slope here. What is true of the slopes of those if the two triangles are similar? So you're
They're the
saying
same.
the triangles are similar, and you're saying angle what is congruent to what other angle?
Well, angle D is congruent to angle A, and angle E is congruent to angle B.
They're all congruent because they're
And
right.
angle F is congruent to
Yeah, and
angle C.
angle F is congruent to angle C.
Yeah, they're all right angles, but they're just flipped.
Well, they could be a right angle. We didn't tell you that.
Right triangle.
They always
They're just made smaller and flipped.
Okay, so
Not
going to be parallel or
okay, so what's really cool about this is that in trigonometry and in pre-calc and calc, we are going to discuss slopes as they relate to degree measures. Okay, so I can tell you that when we do vectors in a certain direction, I want to know what this angle is, and I want to know how long this is. So I can draw a right triangle, and I can use the Pythagorean theorem to find how long that is, if I know how long that is and how long that is. And I can find this angle, because we're going to teach you how to find that angle given 2 out of the 3 sides of a right triangle. Okay, so then I can talk about a boat going a certain amount, maybe 45 degrees north of the east line. Here's the east line, here's the north line. If I want to go 45 degrees from that line and a certain distance, where will that get me? That will get me to a certain point on the coordinate plane. Right? So right now we talk about this point. Maybe that point could be, maybe that point is 4, 3. Right? So describing that point as a location of an x coordinate and a y coordinate is one way. Another way to say where that coordinate is by saying, if this is like the radius of a circle.
11 a.m. Finish the meeting.
It doesn't matter. I have a watch on my hand. I know what time it is. Please do not say what time it is. Okay? We don't stop right at 11. It's a soft target. Okay. So what I'm giving you here is important for the future. Okay. So instead of where we are now is understanding this coordinate is where it is. The slope is how far up and how far over. Delta y and delta x. Here, delta y, we went up 3, right? And we went over 4. Slope is described that way. The location is described as 4, 3. Later on, you can describe this as an r, a radius from the center of a circle, which is this hypotenuse, okay? And the angle that you take, or theta. That's a different way of looking at it that you'll do in Algebra 2 and in pre-calc. Okay? Right now, we're not going to do that. So let's finish this problem, and then we'll stop for the day. What I want you to know is that the ratio of corresponding sides is equal in similar triangles. Okay? So this BC right here over this AC is equal. Now, what is BC? It's the side that's between the 3 and the 2. So the 3 and the 2, that's EF. Over AC here is the side that's between the 1 and the 2 markers. The 1 and the 2 here, that's DF. Those are equal because the triangles are similar. But if you look at what those are, BC is vertical change. AC on the bottom is horizontal change. This is the slope of this line. If you look here, EF is vertical change. DF is horizontal change, which is the slope of this line. So what is true of the slopes of AB and DE if the two triangles are similar? What's true is the slopes are congruent. Why? Because the ratios of corresponding sides are equal. Okay, you can write that. You can write that because the ratio of corresponding sides are equal. The ratios of corresponding sides are equal. And that would be your reason why. So I can write that, and then you guys are dismissed and we're on office hours. The ratios of corresponding sides are We can say
Yeah.
proportional. There you go, folks. And we'll, tomorrow we'll finish up the review. We'll take our time. All right. And I'll see you all tomorrow. Great job.
Mr. Rosenthal?
Mm-hmm.
So, I said the slopes are the same because the angles are congruent. Would that answer be acceptable?
dismissed?
No, because you don't have a complete understanding of why that's the case.
Okay.
Okay. I mean, I can have the congruent angle, right? And I can turn this, I can rotate this triangle and keep the angle the same. That's called a rigid motion. It's a rotation. Okay. It preserves the angle measure and the side lengths, but I rotate it. And now all of a sudden this slope changes, right?
Yeah.
Mr. Rosenthal?
I guess I could have said the same.
By Ms. Rosenthal.
I could have said the same if I rotated it and did it this way, I guess. So I guess that wasn't a
Thank
good
you.
answer. Bye, everybody who's leaving.
What about the vocab on the test?
So no, I think you're right. I think, yes, if the angles are the same, the angles aren't in the same location. This angle's not in the same location as its corresponding angle.
Yeah,
But you
I
know
just
what?
have to. I
On
just have
the
to.
test, I'm going to give these to you on a coordinate plane, so you won't be able to rotate it away. So you'll see it clearer on a coordinate plane.
Okay. Yeah, I just need to elaborate more on the angles are congruent. It's not exactly. Doesn't show understanding. So yeah.
It's iffy. It really. I think that you did demonstrate verbally that you understood why very well by saying the angle. I mean, I thought it was good. That's why I went into that whole other math because of that, because that is a good reason. So you know what? If you can articulate why that's true on your test, go for it.
Okay. Thank you.
Mm-hmm.
Okay. Bye.
Well, I have two questions.
Mm-hmm.
First of all, when can I take the Chapter 8 retake?
There is no Chapter 8 retake.
Okay, and second of all,
The reason why there's no retake is because we cannot bring your grade down lower than than it was at March 13th. We can pick it up, but we can't lower it.
So wouldn't a retake take your grade up?
A retake would take your grade up, but I need to balance. If people can only move up and not down, then that's already an advantage in itself, that you can only move up and not down. There's no penalty for for not doing well on the test, right?
Yeah.
Also the other thing is I'm running out of retakes to give. I know I haven't given a retake on 8. Also, the test security is not valid. It's not that yours wouldn't be taken honestly, not at all. But I have already found 10 students who did not take their tests with fidelity. They shared answers with each other. So it's very difficult for me to tell, if a test is valid. So because of that, a retake is just not a valid way to get you a final score in the class. I really wish it wasn't that way. If you guys were taking these in front of me in class, I would keep doing retakes. But I can't. I tried it. I tried it in the beginning, and once I found that the test was insecure, I figured it would be. But once it was proven that multiple students were not taking it the right way. They were collaborating. I had to immediately shut off the tap because everybody would get A's at the end of the year, and which would be great in one regard. But on the other hand, I would get students that would not know the curriculum going forward into the next school year. They would be unprepared, and I would feel responsible for causing that to happen. So I had to make a tough choice. It was a tough choice.
Yeah. But Mr.
What I can try to work out for you is what I could try to do is if it hurts your grade, your Chapter 8, what I can do at the end is maybe make it not count at all. And if you do well on Chapter 9, I can make it count versus not count. You know what I mean?
Yeah, I know what you mean. This sounds good.
Yeah. So I want you to, I want to not put any obstacles in your way. And by you asking me, you're helping me figure out a way to do it, is to, for students who the 8 is dragging your score from improving, we might just eliminate that, as it'll show up there, but what I can do is make it not worth anything for you.
Okay.
Okay?
Yeah, I got you. And Mr. Rosenthal, can you redo the one where it asks you to graph a line with the slope 0.4 and y-intercept -5?
Yes, I can do that.
Okay, I think I got it. I just wanted to, like, I was sort of confused. Like,
Okay, so the rationale behind the way I did this was that we see slope as a delta y over a delta x. A rise,
overrun.
yeah, the ratio of rise to run. So 0.4 doesn't do that well. Although you could say, you could write 0.4 over 1. You can change incrementally by 0.4. I don't know if you want to graph a change of 0.4.
Can you just
You could count by 0.1, right? Every one of these could be 0.1, right? You could count by 0.1.
That's a good idea.
I mean, you could combat that in your graph that way. But I'd rather just write it as a fraction and use whole numbers, right? Yeah, so I like 2/5 as my slope, and I like my y-intercept as my -5. And as you remember, y-intercept is b, right? And then I'll start here at -5. 1, 2, 3, 4, 5. And from there, I'll let the slope dictate the change in y and the change in x from that point.
Up to over 5.
Yeah, that's it. Notice how many of these marks I'm going to make.
Will there be vocab on the quiz?
No. And there's your 2 points. Use a ruler and connect them.
Thank you, Mr. Rosenthal. That was really easy now you explained it.
Excellent. I'm happy.
Thank you.
You betcha.
Bye.
Anybody else have any questions for me?
Yes.
Okay.
So I'm in the book and I saw a problem that was 8 cubed plus 8 squared plus 2x plus 2. Oh, sorry, x. Sorry, it was x. It was x cubed.
X cubed plus
X squared.
x squared
No, I said 8.
plus 2x
Plus 2.
plus 2. And what was the instruction to do with this? Factor it?
Yep.
Okay. This is a factor by grouping problem. So you're going to factor these two separately than these two. And you're going to hope that you find something in common with what you factor out of these. Okay? So here, what's in common is x squared. What's left is x plus 1. Here, what's in common is 2. And what you find left is x plus 1. So voila, we found something now in common between those two. X plus 1 is in common. What's not in common is the x squared plus the 2. And we're done.
Oh, so sometimes you would have to factor by in separate groups.
And we call that factoring by grouping, which is how I explained to you when there's a coefficient of the x squared term in a quadratic.
Mm-hmm.
And you make that t table, you don't just go right to the answer. You rewrite the problem and split the trinomial into 4 pieces so that you can factor by grouping to get down to your final product of factors.
Okay. So like basically in factoring, all you have to, like, what you do is you look for a relationship between, like, because like in the problem, y to the 5th power minus 8y to the 4th power plus 15y to the 3rd power.
Slow that down. Y to the 5th power.
Minus 8y.
What? Minus 8y to the 4th power.
Plus 15y to the 3rd.
And that's it?
Yeah, they would have y.
Take what? This is not 4, so you don't factor by grouping with 3. You factor with grouping when you have 4 terms. This one has a y cubed in all of them. Now you have y squared minus 8y plus 15, which you can now factor. And that's just going to be -3, -5. So this will be y cubed. This doesn't have a coefficient now. So then you can go y minus 3, y minus 5. You can take the shortcut. Didn't we do that one yesterday?
Oh yeah, you did. I just checked. I was still looking for the using factoring to solve. Maybe it's in 11. Maybe it's in 11. Like using factoring to solve equations. I remember. It could just be in chapter 11.
Or in 13.
Maybe in 13. Oh, they have the quadratic formula. Oh. Use the quadratic formula to find the roots of each polynomial. That sounds interesting.
The roots are the x coordinates of the x intercepts.
Okay.
They're just the x intercepts. Where are the x intercepts located? When y is 0, right?
I found it. I think was solving by completing the square.
Okay. Give me a problem.
Okay. X plus 3 squared. There would be x plus 3 in parentheses squared equals x squared plus 2 times 3x.
2 times 3x.
Yeah.
So 6x?
I mean, yeah, I guess so, because they wrote it like that. So that what you
You sure? Okay.
Plus 9.
Okay.
So would you factor x squared plus 6x plus 9 first?
Wait a minute. This is an identity. This equals that.
Yeah.
So are you sure they're not giving you an example and saying that this is the next step after that?
Oh.
This is an expression.
Yeah.
Yeah, you're not solving this equation because
that's an example.
This is x squared plus 3x plus not. They're filling in this. A plus b squared is a squared plus ab plus ab. So it's 2ab, which is why they said 2 times 3x.
Oh.
That's why. 2 times x times 3. 2 times 3 times x plus b squared. There's b squared. 9. X squared is a squared. 2ab is that times 2. So this is not one where you're solving it.
Oh, just an example.
It's just an example of how you expand that.
Looking for the try this. Oh. Solve by completing the square. X squared plus 8x plus 12. You would just complete the square.
Solve it?
Yeah.
Is it equal to something?
Equal to 0.
Okay. First, can this be factored to solve?
Yes.
So you take this.
It will be
1 times 12, 2 times 6.
6 times 2.
So what you should be getting is x plus 2, x plus 6 equals 0. So x is -2 and -6, right? All right, but doing it by completing the square is different. So what we're going to do first is get rid of the 12, okay? By subtracting it on both sides. You with me?
Yep.
Okay. If to make a perfect square trinomial, then this would have been made by the same thing 2 times. What would something plus itself give you 8x? What would it be?
Something plus itself or times its?
Plus itself, or remember in the last example, it was 3x times 2, right?
So
This term, middle term, is 2ab, remember?
yeah.
So what is 2 of what gives you 8x?
Well, 2 of 4.
Yeah, so that basically all you have to do then is to cut that in half,
2.
right? So if that cut in half is 4, the 4 plus 4 gives you 8, so 4 times 4 gives you 16. And what I have created is it will factor into.
Oh wait.
Right? Because you'll get your x squared. This will be your 4 squared. And this will be 2 times 4x. Will give you the 8x, right?
Yes.
Because we know that that's how a trinomial square works, a perfect square trinomial, then you can factor it directly into this form. Remember, the square root of this, the square root of this, right, gives you, is squared, right? But we didn't account for something that we just added that was not there. What did we add to the equation that was not there in the beginning?
The 16.
And you can't just add 16 to an equation and not account for it. That plus 16 is unaccounted for. How would you like to account for it?
You would have to add it on both sides, so it would be.
Yeah, or there's actually another way you can account for it that we're not going to do right now, but it's a technique that you will use in the future. I could also subtract 16 on the left. What's plus 16 minus 16?
It would be 0.
So I'm adding 0 as an identity, right?
Yeah.
That's okay, right? And then I could factor just these and leave the minus. I could do this.
And minus 16.
See that? But then I would be adding 16 anyway, right? So it would have been easier just to add 16 to both sides. And that's what you do when you complete the square. Now you got the idea of how you complete the square. You get rid of the c, ax squared plus bx plus c, c is 12. You move it to the other side. You cut the b in half and square it. Then you get you factor it into a perfect square. X, the square root of 16, squared. And then you added that 16 to do that. So you had to add it there, and you got that. Now how do you solve the square root of something squared is 4. What squared is 4?
2.
Or
It'll be the
negative 2 squared, right?
So it will be the absolute value.
Ah, very good. So when you take the square root of an unknown that's squared, that unknown could be positive or negative, right? And then when you square it, it'll be positive. So when you take the square root of an unknown squared, it's the absolute value.
Of x.
Is equal to the square. You have to square root both sides. And so whatever's in here could either be 2, or whatever's in here could be negative 2. So you can say x plus 4 can be 2, or x plus 4 can actually be negative 2. And when you take the absolute value, either way, you'll get 2, right? So then you solve each one. And when you solve this one, you get the other one. Isn't that lovely?
Yeah.
And completing the square is how we derive the quadratic formula. So if you really want to understand deeply the quadratic formula, start with ax squared plus bx plus c equals 0. So you don't have any numbers other than 0 there. And see if you can complete the square with that. That's the ultimate practice of completing the square. If you can do it with no numbers, you can do it when there are numbers, no problem.
X squared plus bx.
Once you know how to do that, then you just use we don't complete the square to solve, because we just use the quadratic formula. But you don't use the quadratic formula until you can prove it. We prove it by completing the square.
Subtract c.
Or are you doing that now?
Yeah.
I'm going to let you do that one on your own. Do you have any more questions for me? That would be a good thing to work on. See if you can derive the quadratic formula, which you can look up and see if you can get that by completing the square starting from ax squared plus bx plus c equals 0. Which means that that's when that parabola is hitting the x-axis, is when y is 0.
Yeah. So x squared plus bx.
All right, I want you to work on that on when we leave here.
Okay.
Okay?
Okay.
All right, that's a good practice, and you can struggle with it, and I want you to work with it and not get bailed out. I want you to come back to it, if you need. Maybe you don't need, maybe you can go right to it. Who knows? But struggling with it is not a bad thing. It's a good thing.
Mm-hmm.
Okay?
Okay.
All right.
Thank you, Mr. Rosenthal.
I'll see you tomorrow.
Okay.
All right. Hannah, did you have any questions for me? Or Sylvia? All right, I'm going to end the meeting. Take care.